Thanks, Dirk, for inviting me to this session. It was a very agile planning. So I just got informed that there's a free slot because I had forgotten to submit my talk. So I tried to find something interesting and tried to find something interesting from the projects I'm currently working on. So this session is about how to use HTML and JavaFX, what you can do wrong, what you can do better, and some tricks and some libraries that you can use for that. So I'm Tony Epple. You can find me on Twitter as Monaco Tony. I'm doing training and consulting, and I have a company with our own UI framework that is called JavaScript, and I'm going to show parts of this here, but only in the context of JavaFX. You can use it standalone as well, but that's not of so much interest here, I guess. I'm doing a lot of JavaFX, and some of the stuff that I developed here are coming from my consulting jobs because I had the need to create some stuff in order to help my clients. So some of these JavaFX open source projects were also driven by this need, basically. So giving companies jobs and giving them hard tasks to solve also helps the open source community and fuels these open source projects and brings them forward. So it's always great if a customer allows us to reuse what we've been developing for him also in open source projects. One of the things that I've been doing recently, maybe that's of interest to you, is a flexbox layout for JavaFX. So in case you have been missing something like that, there was once some kind of Kickstarter campaign to create one, but that didn't succeed, so I decided to create my own. You can find it on GitHub. I suppose that Dirk is going to upload the slides somewhere later on, so you will be able to find the link there. Okay, so my takeaway message from this, from watching these sessions is JavaFX charts suck. What can we do about it? And that's one of the things that could probably be solved by using HTML. So the motivation of using HTML in JavaFX, besides showing documentation or something like that, is you can fill gaps, certain gaps that exist in JavaFX, some components that you're maybe missing, and this is also something that I came across a lot of times, is you can integrate with existing systems. So often a time, a company starts developing a new JavaFX application, and at one point they need to integrate with an existing system. We saw an example of that in Tom Schindler's talk, where they had an older system that was based on OpenGL for rendering 3D stuff. And this is also a typical use case for companies to have web-based systems, and it's often a difficult task to integrate those. But I'm going to show you how I would do that and how I've done that. So alternative to the, we've seen a couple of alternatives to the JavaFX charts. One other alternative could, for example, be the HiCharts library. They have very high quality charts, and yeah, a lot of them, and yeah, like these 3D charts and stuff like that. And it would be nice sometimes to have these charts in your application. And using HTML inside of JavaFX is a very simple way of reusing these libraries that you otherwise don't have. Okay. So by default, you can do that. JavaFX has the WEBVIEW component. Who of you has used the WEBVIEW component before? So everybody, basically. I don't have to tell you anything about it. It has a JavaScript bridge, and it allows you to execute script. So you can take the engine there, execute a script, construct some string, put in tons of JavaScript code, and for example, in this case, HiCharts chart would render. But this is definitely not a way to write a nice API. So I've been trying this, and to construct scripts like that is just plain horrible. So we were looking for a better way of doing that. and a way of making it easier to create APIs that you can use to make JavaScript, basically JavaScript calls TYPESAFE. And one way of doing that, let's assume we have this HTML here. We have a span with the ID label and a button with the ID button. As an example, one way of integrating with the JavaScript in a type-safe way is JavaScript body, which is a library by the NetBeans project. And I've linked it here. You can probably have a look at the Java code, Java API docs later. And this is how it is used. So you create a static native class method and give it some parameters that you want to pass, like here in this case, a string and an integer. And then you have the JavaScript body annotation on that with the args up here. They have the same names as the arguments to this method. And it has a body. And the body can contain JavaScript code. And through some magic, this is converted into a JavaScript call. So whenever you call this method, in the context of a web view, I will show you short how you do that. You can call set text, a simple Java method, and give it an integer and a string and your type safe, and this JavaScript code is going to be executed. This is at the very bottom of all of the stuff that I'm going to show you later. So this is basically the way the safest way I know to integrate now with the JavaScript API. And I've shown you how to execute JavaScript. You can also pass Java objects to these functions. Then you need to mark the JavaScript body annotation with Java call is true. And then inside of your Java JavaScript code, you can call methods. Like here, in this case, it has a, I'm calling this runnable, run. I can also pass parameters. There's a special syntax for that. You can find that in the API docs, but also the annotation processor will check the syntax. So if you have an error in your syntax, which can happen when you write strings like that, you will get, it will not compile. So it's also safe at compile time to make sure that your Java calls are always correct. And as you don't want to put all of your Java code inside of a string, inside of an annotation, a JavaScript code, inside of the string of an annotation, there's also an annotation that is called JavaScript resource. And JavaScript resource basically loads a script in the background, so you can put all your utility functions in there, and in the JavaScript body only call these functions. So this is a clean way basically to organize your JavaScript, or the cleanest way that I know to organize your JavaScript and to call it from Java code inside of JavaFX. And the last thing that we need to do is we need to execute that in the context of a web view. So this is a method, FX browsers load. You pass it a web view. You pass it an HTML page. And then you can pass a runnable. And the runnable will be executed in the context of this web view. So in this case, we created an register button action method before. You saw that 2 slides ago, or 1 slide ago. And you pass a runnable here as a lambda, which calls HTML controller set text. That was the other method that we created on the first slide with a string and an integer. So to go back, we have the label here, we have the button here. With JavaScript body, we can set the text of the label, document get element by ID label, label text context is text, and in here we reference the parameters that we passed. And here we registered the button on click listener, the function, which in turn calls Java function. And so the magic that is happening actually is through a Maven plugin. And this Maven plugin, if you add it to your application, is looking for these JavaScript body annotations and is basically processing these annotations to make these native JNI style calls really work. Yes?
Does it require any runtime dependencies?
Yes, it requires. It has some runtime dependencies. I'm going to show the dependencies later. There's a couple of libraries that you need. Okay, so first I'm going to show this demo. And yeah, you can see it here. So we have our HTML controller code. Can you read it back there, or should I increase the font size? Okay. So here you can see the JavaScript body annotations. That's just the same as in the slide. And now you see them in the context of our JavaFX. So we have a tab pane, we have some FXML, and at one tab has FXML, the other one will get the web view. And here we have this FX browser's load, and inside of the context of the web view, the HTML controller register button action is going to be called. And so you can see everything with Hello World in 2018. Okay, so we have the example in FXML, and now we have an example in HTML, and it works just fine. So it's really a simple way if you have to make some simple JavaScript calls in the context of a web page. But you can also use it, and that's what we're using it mainly for, creating your own APIs on top of it. The cool thing is it's browser independent, because the JavaScript bridge from JavaFX is just the way it works in JavaFX. But if you have a different browser, it will work differently. And for JavaFX, there is another browser that is the JX browser. Who has used that? It's basically, wow, that's a lot. It's basically taking Chromium and embedding it in a very current version of Chromium and embedding it into JavaFX. So you can do all the fancy stuff like WebGL and Bluetooth, low energy API, all that stuff is available from there, but it's commercial. And for our use case, we also use it in different contexts. For our UI framework, we can use it in external browsers, so we can just launch a browser and render the UI in there and bind to that from Java code. And we can also do that on iOS and Android. And we can even do that completely in a browser with a special JVM that runs completely in the browser. But for this is basically the part that is not so interesting for you. The JavaFX part is we have WebView and we have JX browser, and we can use these two. So we want to get rid of JavaScript altogether. And in order to get rid of JavaScript altogether, we simply use this JavaScript body annotation in the background and create APIs that you can reuse then. So for example, there's an API that wraps the leaflet JavaScript and gives you a Java API for that. We also have a Canvas API. Actually, it was very interesting to see the talk about JFree charts, because we've done something similar, and we've implemented graphics 2D on top of the HTML5 canvas. So we can actually render some stuff from inside NetBeans inside of the browser. And we also have a charts API based on high charts that you can use inside of your application. And we have automatically generated APIs because everybody in the JavaScript, or a lot of people in the JavaScript world, are moving to TypeScript because they realize that having this dynamic nature of JavaScript is not always the best if you want to create larger applications and if you want to cooperate with other developers who maybe do not want to read all of your code. So for example, we have automatically generated, so for TypeScript, there are so-called type definitions. So you have these typedef files that you can use to have a typesafe version that calls JavaScript library. And we're using these type definition files to generate Java APIs and automatically, and you can use them. For example, we have tons of them. jQuery, Snap SVG, and so on. All of that can be generated. You have to test them, and you have to maybe fiddle a little bit with them, but they are generated automatically, and you won't need to worry about JavaScript directly anymore. So let's have a look at the leaflet for J as an example. That's how you would create a map view in JavaFX. So map view map is new map view, and you put it in a border pane. Then you add a list view to the left of the border pane, and you add some list view items with coordinates. That's the first part. And then list view gets selection model, selected item property. So you listen basically to what is selected in the list view. And whenever that selection changes, you call the FX browser's run in browser to run the code in the context of your web view. And then you can do stuff like set the view to a certain position. As you can see, it's a regular Java API, and it's a typesafe Java API. And you can open a pop-up to show something there, all with a Java API. And I would like to show you that too. So here you have a map, and apparently I did this for the Chuck Münster once. So Gerrit invited me probably. So here's the Chuck Münster, at least that was where the talk was. And this is where the creator of NetBeans is sitting in Prague. And this is where my company is located in Munich. So you can use this component just like any other JavaFX component in your application, and you can move it around, you can zoom in and out. So so I don't have an API key, obviously, because this is an open source project, and I don't put my my API key there. Okay, there's a question.
Does WEBVIEW works well in off-screen rendering? Can we just render a page, a map in off-screen and do a snapshot, for example, or do we necessarily have
I have never tried it in that context, so I cannot actually tell you. So I haven't never used it for off-screen rendering, but we would have to try. And it works. Oh, there you can actually see my bar. I just noticed that. There's Tony's bar. I wouldn't recommend to go there. The nice thing is this is available for free. The bad thing is WEBVIEW is not the very best browser in the world. So so a lot of you have used WEBVIEW. So you probably know that it's not the most performant browser in the world, and that it's not supporting all of the HTML5 features. But the cool thing is you can replace it with JX browser at any time if you want to split out the money for it. And the cool thing is, another cool thing is that it's a really drop-in replacement. So with our APIs and with this JavaScript bridge that we are using under the hood, you're not bound to a certain to a certain browser, but you can actually have a drop-in replacement. So if you find out in the course of your project that WEBVIEW doesn't really isn't good enough, the performance isn't good enough or something like that, then you can simply replace it without throwing away your code and having to rewrite everything to the JX browser JavaScript bridge. We did that for you. So the next thing, so these were basically directly based on JavaScript body, these APIs that we've looked at. But we've got a higher level API. And this higher level API allows you to use HTML like FXML in your application. And that's actually really cool. Because I'm a big fan of this model view model pattern that we've heard about a couple of times now. And we're using that. So what we're doing is we're doing no JavaScript code at all, but we're doing completely declarative bindings there. And we bind the HTML elements inside of your WEBVIEW or your JX browser or whatever to view models which are written in Java. So by default, so up until the 1st November of this year, we always did that with our own model API. So we have a model API that allows you to define model classes and properties, and these classes will be generated for you, and they will automatically integrate with this structure and APIs. But for JavaFX users, this is just another API they would have to learn. So we decided that we allow it to create a project that allows you to use those JavaFX properties directly. So you can now bind HTML elements and their attributes to Java models with regular JavaFX properties. And I'll show you in a minute how that works. The project that we've created for that was FXBEANINFO, because I had a look at the FXML loader, and I found the code horrible. Not that it's badly written code, but it has to do a lot of guesswork. It has to do a lot of reflection. It has these bean adapters, and it's highly complex code for something that is actually quite simple. And one of the parts that is really also complex is finding the properties that are related to the elements in the FXML. So I thought, why not create something like the bean info that we had in Swing that gives you access to the properties that are supposed to be bound. And that's why I created FXBEANINFO. And FXBEANINFo, so just to make sure, do all of you know the model view model pattern? Oh, that was a yes. So in FXML, it's almost implemented. If you use some additional libraries, you can implement it. One of the problems is that in some parts, the view model needs to know about the view, and it has the nodes injected. And in our implementation, we cannot have that because we're supporting, we do not need JavaFX, so we can run on different platforms. So we have to implement the model view model pattern in full. So the FXBEANINFO API can be used like this. So it probably looks quite familiar. You have FXML loader, you load an FXML file, and then you put it somewhere. And you now also have an HTML loader. You can load HTML from a URL. The only thing that is different is that you pass a controller directly. It's not derived from the HTML. And then you've got your regular node, and you can add it to your application. And the the HTML controller is basically a way of for easily enumerating the properties and the actions of your Java bean that you want to expose. So this is the dependency that you will need for the BEANINFO class. That is a runtime dependency. And this is how you expose the properties. So here I have my HTML controller class, and it implements a single method interface called FXBEANINFO provider. And you can almost guess what this single method does. It returns FXBEANINFO. And then you define your regular JavaFX properties, like the string property here, which has a name, which has a bean, and which has a value. And we have this convenient builder here that allows you to build BEANINFO, FXBEANINFO, new builder, property, label text, build. Now you have your BEANINFO, and you can return it from the. That's how you implement it. So it's very simple. So this is for regular properties, a string you want to bind to. But you can also have actions. And this might look a little bit strange, but if you think about it, it's quite useful. You can also have event handler properties. And these event handler properties are basically used for modeling the actions. So the value is, in this case, the event handler. And in your FXBEANINFO builder, you add them via the method action. So now we have added an action, and we have added a string property to our FXBEANINFO. And the cool thing about that is you do not have to instantiate the view. We haven't created a view at all so far. But we can already test the complete view logic. So what we can do is we can, in a unit test, instantiate our controller, get the BEANINFO from it, get a specific observable, like in our case, the string property label text, make sure it's empty in the beginning. Then we get the action from the FXBEANINFO. We invoke the action, and in the end, we make sure it actually changed the text. So what is really cool about this controller, compared to an FXML controller, is that you do not have any dependency on the view technology. Therefore, you do not have to have event dispatching thread. And therefore, you can simply test everything in simple unit tests, all the logic completely. So I think there is one framework by the guys Saxonia Systems for a model view model that also allows you to implement the model view model pattern. But here you have it out of the box. You don't have to do anything. So now how is the binding done? So how do we actually connect the Java model with the with our HTML elements? So what we're doing here is we're basically reusing a very stable and old project that is called Knockout.js. It's I guess it's about 15 years old already, and it's owned by Microsoft. So basically, that's centuries in JavaScript years. But it has a very, very stable API, and it has a very nice API. It's purely declarative. So like here with the data bind, I have this attribute on the element that makes sure I'm doing a binding. And then I have some predefined bindings, like the click binding or the text binding. And I have the FXBEANINFO property that I can bind to. So the text of the label is bound to the label text property, and the button click is bound to the action, named action. So this is how the wiring is set up. And then in the background, it is automatically, so these bindings are automatically set up and via the HTML loader, and you can use your application. So now I'm going to show you basically the same demo I've shown you before, but this time without JavaScript. So here we have the HTML controller. Implements FXBEANINFO provider, defines the properties, creates the BEANINFO, returns the BEANINFO, and registers the action that is supposed to happen. So I'm not dealing with JavaScript at all. And on the other side, I have some CSS, and here I have the bindings. And it's pretty cool because you have code completion and everything in the editor if you're using NetBeans or any other editor that knows how to deal with Knockout. And a lot of them are doing it because Knockout has been around for a while. So this project is available on GitHub, so you can play around with it. So let me simply run it. So here we have our FXML demo. Here we have our HTML demo, and well, apparently it's working. So you can now basically work with HTML inside of your JavaFX application without needing to deal with any JavaScript at all. So this was a very simple demo, but I've got a slightly more complex demo in there in the project. It's a to-do list application, and the to-do list application shows you how you can create nested hierarchies of objects. Like here we have a to-do element which wraps a string property, and again we create an FXBEANINFO from that. And we use this inside of another bean. And here you can see we have one editing. That's the property that is currently being edited, the to-do element. And we have a list of these to-do elements. We can also have list type properties. And that's the nice thing. That is something that you do not have in FXML. You can declaratively iterate or loop over list type properties. So what is basically happening is the part that is inside of this list, of this unordered list, so the list items are repeated for every single element that is in the list. And so they're basically used as a template. And the elements in here are bound to the to-do element that is currently iterated over. And you also have conditionals. So in this case, I display one part of the DOM when I'm currently not editing this, and another one if I'm currently editing this to-do element. And so I can do it. So the bindings and stuff is very well documented. So I put a link to this documentation. I've got my own documentation on the JavaScript page, but you can simply use the regular knockout API documentation, which is very good to find out about the syntax of these bindings and what bindings are actually available. So here is my documentation, so you can look that up. Okay, so let me show you the second demo with the to-do list. So we have the to-do list HTML controller. And well, you can see it's slightly more complex. It has a couple more actions, and it also has one special action, and that is called the action data event. It's an event handler that has an action data event. That is necessary because sometimes I need to call a method that is out of my context. So for example, from the to-do element, I need to call, from the context of the to-do element, I have to call a method that is in the to-do list HTML controller. And in that case, I need to pass the to-do element as a payload. So the to-do list HTML controller can actually deal with it and remove it from the list or edit it or do something with it. So here's the example. And I can add a new to-do. Like this. And I can remove them, and I can directly edit them in place. And that is all of that interaction has been done simply by binding, by purely declarative bindings. And as you've seen, I've not written a single line of JavaScript code for this. Okay. So I already mentioned that the WEBVIEW is not really the best browser in the world. If you don't want to use it, you can simply replace the dependency to the project with a JX browser presenter. and then you can directly use that. The HTML loader in that case is slightly different. So this is really the only difference between the, at least as of now, between the default web view and so in this single class you would need to make a change. But that's it. All the rest of your code will stay just the same and it will still work the same. And for me, the use cases for this kind of integration are to first fill the gaps that are inside of JavaFX, some components that are missing. We must admit the community of JavaFX is great and it's fantastic and it's cool that it's there, but it's not as big as the community that creates JavaScript libraries or HTML. So if we can complement what we already have, the stability and the structure and the runtime performance and everything that you have in a JavaFX application with something on the web, that is fantastic. I'm pretty sure that we could even run JPro inside of the of the browser that we embed in here. And another example where it's important to be able to integrate with HTML is really in the business, in the enterprise. So, for example, last year I had to do some integration. It's a big company and they have an existing system that is able to, for example, render a full car with 60,000 parts 3D based on WebGL. It's a really, really cool library that they are using from the Fraunhofer Institute. And they wanted to integrate it into their JavaFX application. That was basically not a requirement at the beginning of the project, but it became a requirement like 2 years in the project. And so the guys asked me, how can we do that? And I said, like, well, use that. Use JX browser, embed it in here, use a clean API, and it will work. And it does work, and I can show you the demo. This is not I cannot show you the actual demo, and I cannot, so I'm just showing some random demo that also does some WebGL rendering and is not related at all to anything that I was talking about. Oh. Weird. So it will take a while to build because this project that I created, the demo project, contains a 3D library in JavaScript. And this 3D library is quite large, so it will stop here while building the jar file for a while. Yeah, for a while or two.
You said that it's also working on iOS?
That is a different framework. So this has nothing to do with this embedding. So this is a JavaFX application, just the same JavaFX application that I've shown you before with the to-do example and that stuff. And you can have this car model in here. And when I click one of these buttons, it will invoke Java code, and through the JavaScript API, invoke the functions completely hidden to the Java developer. So I think this is a really powerful technique, and so it's basically the same approach that Tom used for integrating OpenGL, integrating an existing system that you cannot rewrite simply in JavaFX. You cannot write a component. Or you cannot write a component for little money that renders a full car in 3D with JavaFX 3D. You could possibly do it with OpenGL somehow, but it's a lot of development if you have to redevelop everything. So using JX browser, using the WebView inside of your application gives you a really, really good way of integrating that stuff. So, in conclusion, I would say the default JavaScript bridge is painful because it requires you to construct these strings. If you want to have some simple JavaScript calls, use JavaScript body. It's just a Maven dependency or a couple of Maven dependencies that you will need. And it will give you a very nice way of calling JavaScript in a type-safe way. And it also will give you a way of calling JavaScript in a type-safe way that can be ported to JX browser easily. The WebView is okay for most simple use cases. If I would like to embed a map in a simple application, and Leaflet is just fine, it's free. JX browser, so if you need more performance, if you have tons of markers on the list, or you need faster rendering or something like that, JX browser is great for all the other use cases. It has some problems, so we used it heavily because our framework is really pushing Java objects into the browsers and interacting in a heavy way, and we realized that JX browser does not have any garbage collection, which is not very good. But we worked around this problem. So right now we're basically passing pointers in there and doing the garbage collection or the object management. Java does the garbage collection outside of the context of the JX browser. So this problem, memory leaks, are solved as well in our JX browser presenter. The presenters that we created allow a painless switch. The default WebView presenter is by the NetBeans team. It's Apache licensed. It's basically it's available for free. Apache license should be very permissive. And I think it's a good idea to start with WebView, see if it gets you where you want. And if it doesn't get you there, maybe give us some money so we can give you the great JX browser presenter. Or just do something else or switch to something else. But I think it's really a path worth exploring, and it solves a lot of problems in a very, very simple way that you would work very hard to solve on your own if you only use JavaFX. Yes, Johan?
Are you using JavaFX 11 WebView?
I have tried it. It's working. So all our tests are working. But I found that if I use it on its own, it's not very stable. Yeah, but I found some problems because I used it like last week. I tried a couple of things, like for example, if you try to open JFX.io in the WebView crashes. Or if you open HTML5 test in the WebView crashes.
Works for me.
It works for me, yeah. I would love to make it to contribute to that, and I would love to discuss with you how we can contribute, because it's in our own best interest that the WebView performs great.
Yeah, there you can find an issue at GitHub.
Yes.
Or /JavaFX/OpenJDK/JFX.
Yeah.
And that's a good use case. If that question then.
Yeah. Well, I mean, the test is very simple. You just have to open a couple of the problem, I guess, that exists at the moment with the build infrastructure is that WebView is not actually tested. It's in the continuous integration in the Travis build.
Yes.
Yeah.
But all the tests before we do the builds, all the tests
Yeah.
run, and we occasionally put in new WebKit code into OpenJFX.
That's great. That's fantastic.
And between 8 and 11, there have been major updates in WebKit that we imported. So
Yeah.
I agree it might be less stable now because
Yeah.
basically pull
Sure.
big pull, but the performance should be much better.
Cool. Very good news. So you won't even need to shell out the money for the presenter. You can use it right away.
Yeah, I'd say for us, WebView was not just about performance, but just of being able to use a lot of the new JavaScript stuff. Build new Angular, etc.
Okay, cool. So thank you very much for your attention. Thank you, Dirk, for this great conference. And Dirk wants to say something now.
Yeah,
Okay,
just,
thank you. If you have sorry. If you have more questions, I'll be around.
Okay, so this concludes day 2 of the JavaFX days. I hope you guys all had a great time.
think there was a lot of information to digest and a lot of things for you to think of and maybe to incorporate in your applications. Gerrit was so nice to tell me that I probably forgot to order beer for everybody, but we can all just meet downstairs at the bar, but unfortunately you will have to pay for it yourself. That was not in the budget anymore. Okay?
It's okay as long as there is beer.
Oh, I thought you were about to say that you will pay.
It's okay to have some beer.
The Finnish delegation is buying. Okay, thank you all for coming. Thank you.
Thanks for organizing it.